So in today's class, we will try to understand. Is my video enabled? Just want to check. Okay. Okay, great. So we will learn some basic sorting algorithms. You will learn quite a bit about sorting in other classes in data structures course. But we will study at least couple of algorithms we will try to study. So one algorithm is BubbleSort. And another algorithm that we will be studying is merge sort. So these two algorithms we will study for we will study in this course. And so in the BubbleSort, let's see the logic for the BubbleSort. So the BubbleSort algorithm is really simple. In fact, I feel really happy about BubbleSort because when I was in my UG1, so yeah, so this is what I did. So something like there are a list of numbers 12 minus 1, 30, 21, 18. Let's say these are the numbers we have. And so in BubbleSort, what we do is, we start with the first number here. We start with iteration 1. This is iteration 1. So I1 is iteration 1. In iteration 1, we start with this element 12. This is what we have here. We start with the element 12. We compare 12. This is like when, when you are on ground, when you are trying to sort people, this could be one simple way of doing it. So you compare 12 with minus 1 and you want to sort in ascending order. Okay, so ascending order, the final output that we are expecting is, minus 1, 12, 18, 21, 30. This is the ascending order. So what do? We compare 12 with minus 1 and 12 is greater than minus 1. So we swap, so compare 12 with minus 1. 12 is greater than minus 1. So we swap 12 and minus 1. And this is the list that we get after we compare 12 and minus 1. And so this is the element that we are fixated on. We want to find the position of the element 12, not the position of the element 12. We want to keep, we start from here and we want to bubble up the largest element. We currently think that 12 is the largest element. This is our estimate. And since, so minus 1 is less than 12, we take this shorter guy front and we take the bigger guy this way. And now we compare 12, this is now 12. We compare 12 with 30 and 12 is less than 30. So what we do is we leave 12 as it is and we move to 30. 30 is the current element that we hold on to. And then we compare 30 with 21 and it happens that 30 is greater than 21. So what do? We swap 30 and 21. So we get this. And now we compare 30 and 18. 30 is again greater than 18. So we swap here 18 and 30. So as long as an element is the element that we are putting our finger on, if it is greater than the next element, we swap. So here we did a swap. We did a swap here because 30 is greater than 21. In this step also we did a swap, 30 is greater than 18. But here we didn't do a swap. We didn't do a swap here. So 12 is less than 30. We moved the finger. So move finger. That's what we did. And here also we did the swap here. This is the whole thing that we did here. It falls under iteration. So this is the original element. This is the original configuration of the list of elements. And after the swap, the state of the list changed to this, and then we moved the finger. When we move the finger, the state of the list doesn't change, it remains as it is. But then after we move the finger, so you can see, this one, so both these two are the same because we just moved the finger. But then here we did the swap, we went to the next state, the state of the list changed, and then finally, again, the state of the list again changed. So at the end of this iteration 1, we know for sure the element here is the largest element. 30 is the largest element, and we don't need to worry about it. Like we got the biggest guy, we kept him in the last. Now we can focus our attention on the rest of the elements here. Are you all with me on iteration 1? And now we repeat the same exercise. We recurse. So we were talking about recursion in the last class, right? We can recurse. So this is iteration 2. So you can see what is the maximum number of steps that are possible in iteration 1? In iteration 1, if there are n elements, how many maximum? N minus 1, n, okay, yeah, maybe n minus 1 steps. Okay, max n minus 1 steps. Even we can think of it as n, not a big deal, but let's say n minus 1 steps. So in iteration 2, what we are doing is we just focus on, we just leave the 30 there. Okay, it will be there nominally, but we don't care about 30. We just leave it as it is. And we put our finger on minus 1. And we compare minus 1 with 12. When we compare minus 1 with 12, 12 is greater than minus 1. So we just move our finger, move finger. We say, no, so hey, this is what we are in. So the state, whenever we move finger, the state of the system didn't change. Okay. Now we compare 12 with 21. So again, 21 is greater than 12. So we move finger. So now when we move finger, so what we have is 21 and 18. And then we compare to 21 with 18. And when we compare 21 with 18, then 21 is greater than 18. So we do a swap operation. And then we stop here. So now we know for sure 21 is the largest element in this prefix list. So in iteration I3, so again, if you see, the maximum number of steps are n minus 2 steps. And here we can see minus 12, 18, and 21, 30. We don't look at 21 and 30 here. Now we put our finger on minus 1. And you compare minus 1 with 12. Minus 1 is less than 12. So we just move finger. We don't do anything. Okay. And then, so now minus 1, 12. So 18, 21, 30. You compare 12 with 18. 12 is less than 18. So you don't need to do anything. You just move your finger. N is the size, number of elements in the list. Okay, so that's all. So I have an interesting question for you. In any particular iteration, if all we did is moving the finger, then can we safely consider that it is already sorted, the sublist is sorted? It's like this, no, like no. That's what we do now in a on a ground when you are sorting all the players within a group. If they are already in a sorted order, you keep moving your finger all the time. There is no swap that is required. Then we can safely consider it is already sorted. So only moving finger, no swaps, then that means the list is already sorted. No need for going to iteration 4. We don't need to go to iteration 4. We are considering swap comparison as a one operation, one step. Comparison, even moving finger, every step either you do comparison and move finger or comparison and swap. At every step there are two possibilities. Compare, based on comparison you either move your finger or you swap. Yes or no? That's all, no? You compare and either you move your finger or to swap. That's all it is. So if you think about in the worst case, what can happen is in iteration 1, if there are n elements, so time complexity analysis, if you see, in iteration 1, n-1 comparison operations, comparison, and let's say compare and move finger or compare and swap. We just think of it as one operation. In iteration I1, we will have n-1 operations. In iteration I2, n-2 operations. So on, if you look at in iteration in-1, we will have one operation. So the overall number of steps is sigma. What is the overall number of steps? Sigma I is equal to n-1 to 1 I. This is nothing but n-1 into n by 2. And we will say this is roughly proportional to n square. This is roughly proportional to n square. So why is it that we kind of think of it as roughly proportional to n square? Because what happens is if you take n square divided by n-1 into n by 2, limit as n tends to infinity. What is this limit? This is equal to 2. 2. It will be 2, I think so. Yeah, it is 2. That is some constant. So what happens is as the value of n really increases, then like the difference between our estimate of n square, we are just off by a factor of 2 at the most in terms of our estimate of time taken. So we kind of consider it as proportional to n square. This is what is called as an asymptotic analysis. What happens as the value of an asymptotic analysis? Are you fine with me on this story? This whole the algorithm and the analysis. So we don't say n square by 2. N square by 2 also you can say, but this constant we don't care, because constant is it's not so important. In most cases it's not important. I want you to know it's not like it could be the case, Vaibhav, that n square by 2 will take half of the time as n square. But when you want to do that n square, the constants when we want to consider, then you really have to account for, we are doing the compare and move finger, yeah, or compare. There are so many nitty-gritties we have to consider. but we lose the big picture. That constants become important in some cases, but but in many algorithms we don't worry about the constants. N versus n by 2 doesn't matter. Yeah, that's true. And n is very big, then n versus n by 2 doesn't matter. So now shall we write code for the bubble sort and see how it works? Yeah, it's the goal. So you should all help me out here. This is a reasonably complex program. So how should we do? Let's do one thing. I'm just trying to get the print statement, print function. See, in the other day, in the tutorial session, some of you are asking about difference between ++i and I++. By this time, you should have figured out. Yes or no? Yeah. Okay. So let's see if it works. I am just interested in first printing this. Read array. Okay. Let's see, let's compile this program and see what happens. Are you able to see? Yeah, I think you should be able to see. So what is the problem here? I entered end of file. When I press Control D, I entered 10, 20, 30, and when I press Control D, then that means it's end of file. So it's a neat way of entering input. Other ways, so there are other ways of doing it, but you enter 10, 20, 30, and then I press Control D. Then scanf will return end of file symbol, and that means we finished reading. But here the problem is we are returning the size of the array. So how many of you understood why we are getting, we entered 10, 20, 30, but the output is 10, 20, 30, 0. Why is it? Yeah, that is because size plus plus. End of file, it is included, no? So we should not, so the size should be, what should I return here? We are returning, yeah, so we should return size minus 1. We are, even when we are returning, we are incrementing size when we are supposed to just end the input, no, reading input. So we have to return size minus 1. Everyone with me here? I think some of you may be lost. So what is happening here? Clear all my. So size. So in the first iteration, what happens when we enter the while loop? Size is 0, and so we are reading a of 0. 10 is assigned to a of 0, and we have incremented size. After we came out, after the first iteration is finished, we are no, the value of size is equal to 1. Pay attention. And now a of 1, so a of size plus plus, right? So what happens is we use size is equal to 1. So what is the semantics of size plus plus? What will this expression means? What does this expression means? What is the return value of this expression? No, the return value, if size, let's say the prior value of size is equal to 10, what will this expression return? This expression returns 10, and after it returns 10, it increments it by 1. Yes or no? It returns 10 and then it increments it by 1. So here the initial value of size is equal to 0. So initially we use, we read into a of 0. And after that, what happens is this plus plus gets incremented. Okay, that size gets incremented. And similarly, when we again come to in the next iteration, we read the value of size is equal to 1. And then after the value 1 is used, size gets incremented by 2. And a of 2 is 30. And then we get 3. And then here at a of 3, I pressed Control D, which makes scanf return end of file symbol. And so in the previous case, when it read one input, it returns 1. Whenever scanf returns the number of fields it is able to successfully read. So initially scanf returns 1. Here it returns scanf. In this case, returns scanf. It returns 1. Two things scanf does. Scanf returns 1, but as a side effect, it updates the element A of 0. Are you with me? Scanf is doing two things. It is returning the number of fields it has successfully read. Okay, so when it read 10, it returns 1. When it reads 20, it returns 1. When it read 30, it returns 1. When it encountered Control D, it returns end of file symbol. But as a side effect, while it is returning the number of fields it successfully read, as a side effect, it is updating. As a side effect, it is updating the memory location associated with element A of 0, A of 1, A of 2. So this is the side effect. This is side effect column. That this assignment is happening because of as a side effect. Are you with me? Are you all with me here? The difference between the return value and side effect. And many programming languages, they don't like side effects, but in C we are fine with this. We want to do everything in a very clean way, no side effects. So Santrupta Singh, we discussed about this many times now, that we are passing the address of A. What is happening here on line number 26? We are passing the address of the array which is declared on line number 24. Does this make sense that that on line number 26 you are passing the base address of the array defined in main? Yes or no? On line number 26 we are passing the base address of the array A. So this base address, we are passing this base address. Once we have the base address, we can modify all the elements. Are you happy? Okay. So now, yeah, what's the next step? The next step is, of course, we want to sort. Yeah, so void BubbleSort So Amoga, you just print what happens, write the code and try out. So scanf returns 1, it returns the number of fields it successfully read. When we press Control D, then it says it doesn't return 1. When we enter 10, 20, 30 or any integer, it successfully reads them. But when we press Control D, it returns end of file, in which case the condition on line number 8 gets violated and we come out of the loop. We need a termination condition. We want to come out of the loop. The termination condition is when we hit an end of file symbol in the stream, then scanf also returns. Look at the semantics of scanf. Write few experimental small toy code and check what is happening and see if it makes sense or not. See, I want to tell you one important thing here. The problem with C is this. the scanf, these are kind of idiosyncrasies of the language. It's not like there is any serious algorithmic logic there. Okay, these are some idiosyncrasies of the language. So whenever you face some idiosyncrasies with the language, what should we do? There is a logic and there is a language. Okay, take advantage of them. Okay, adapt logic and language, accept and move on. All good answers. You should check the textbook. What is the idiosyncrasy that is there? You just have to look at the book. Like for example, you can look at Essential C or your textbook and understand, what is this peculiar thing about the scanf function. And if you understand it, then you just remember it and use it. I want you to distinguish between logic and language, logic versus language. Logic versus language. So scanf has some idiosyncrasies, and there are other ways of doing this. Like for example, perhaps something which would have made many of you happy without getting into this trouble is this. Okay, printf, I could have done that. Enter the size of the array. This code would have made you happy actually. You read the size. Scan % size, and then what happens? For I is equal to 0, I less than. Would you be happy with this? Yes or no? Does this make sense? In fact, you can make it slightly more interesting to say, you put does this new array so let's comment this code out. There is no confusion in the new read array function, right? And in fact, you can say if size greater than, max array size, printf cannot store that many elements. Okay, so does this code make sense? Are you all with me here? So let's run this program and see whether it will work or not. I have to, okay. have to include stdlib.h because of exit. At line number 14, the return value on line printf exam, the number of characters printed. On line number 15, we are exiting from the program. Okay, we are exiting from the program. It's like, you know, main calls read array, and from read array, hey, things went bad, and you know, you just exit from the whole program. Let's say the size of the array 300. Now we are out of the program. And let's say the elements we give are 4. Yeah, so 10. What happened? Scan. Yep. I see. I kept a slash in here. Let's compile this program again. And also, I didn't like this thing. I just have. Are you happy with this new read array code? Because we are not doing any magic in this new read array code. We are just reading the size of the array, and followed by that we are. But what's the problem? Do you prefer this read array code or the previous one? Why do you like the previous one? Yeah, the primary thing is compact. Other thing is you don't need to know the size of the input a priori, right? Because otherwise, no, size of the input is a pain, right? So you need to count before you figure out, before you try to read it and store an array. You need to make up your mind and. Array, forget about OJ for some time. No, there is a logic. Let's try to understand language. Let's try to understand logic, and no, we will deal with OJ later. Okay. So, anyways, so now we want to do this BubbleSort program. Okay. So BubbleSort and int size. So you help me out here. For int I is equal to 0, we start with maybe we start with I is equal to 1. I less than size plus I. If A of I is greater than, if A of I is less than, if A of I is less than, if A of I is less than A of I plus 1, what should we do? I is a finger. Right now, when we start the sorting, we put the I on the I, we put the finger, I is the finger, we put the finger on element 0. We continue. So remember, I didn't introduce the continue statement. Continue means you just go to the beginning of the loop again. Okay. So actually, this is, otherwise, we want to swap A of I with, let me use, for the, I don't want to introduce again. Temp is equal to A of I, and A of I is equal to A of I plus 1, and A of I plus 1 is equal to temp. So here it doesn't matter. I think, see, that the problem with plus I and I plus plus is they don't give you anything, but it just keeps here. It really doesn't matter on line 48 whether you use plus I or I plus plus, all those things, it really doesn't matter. Okay, so does this code work? So what will this do? What will this code do? It bubbles up. This is only one iteration, right? Int temp. Let's compile this code and see what happens. So give me some input. Give me an input of 4 numbers. Five, 7, 3, 8. Let's use 5, 7, 3. I will use -1. What do you think will be the output? At least what will be the last element? You have what happened? I didn't call BubbleSort. Yep. Awesome. BubbleSort A size. Five, 7, 3, -1. You see that the whole element is not sorted. Only 7 got, we just kept, we did only one iteration here. In this code, how many of you are you all with me here? That after executing this code, we are able to bubble up the largest element to the last position. And that's all, we didn't do anything. I hope all of you are with me that by writing the loop on 49, it only bubbles up the largest element to the last position. So one thing we can do, we can use an iterative version. We can solve this problem in a recursive way. So we still have to sort. Does this work now? On line number 60, we have sorted, now we want to sort the rest of the elements. Does this work? BubbleSort A size -1. We need a base case. Excellent. So what is the base case? If size equal to 1, you don't do anything, return. Okay, so there is this idea we can solve this problem using a loop, but will this solve the problem, this BubbleSort? So the reason why this is clean is, you can think recursively. Take the largest guy, put him in the last, and then recurse on the rest of the group. Okay, are you with me here? If in order to, in terms of picture, if this is your whole array, after the for loop, what will this for loop do? This for loop, it takes this array and transforms this array so that the largest element is here. Yes or no? And this is done by a sequence of swaps. Are you all with me? Now what you do is, Now for the rest of the array, you again apply the bubble sort. And you keep on doing it. Finally, when the size of the array becomes equal to 1, when this is the size of the size is equal to 1, you don't need to anything, you just return. Does this make sense? Okay. So now let's see if our logic holds. What's the previous elements we used? So suggest me some elements. -2, 10, 0, 5. Yeah, now it is sorted. Are you happy that it is sorted? Now, how can we optimize? If there is no swaps that have happened, so we can do one small thing, swap underscore count is equal to 0, and so plus plus swap underscore count, and we call if swap underscore count is greater than 0, then only we will call the recursive version. Otherwise, the program is already, the list is already sorted. Does this make sense? That when if we just keep moving fingers, we will always be going to line number 59. So we never go to line the else part. And there is no return. This is a void. This doesn't have, this bubble sort has only side effects. It doesn't return any value. It is already sorted. So we are, if swap count is less than, we don't need a else here. Okay. Initialize the swap count to else in the else. Why is it? Okay, so see, I have a question for you. Like, so now we are able to get the output. Does this mean our swap logic is good, is right? Does this mean that the code that we have introduced is this right? Okay. We have to check, we have to take a use case where it really happens. And that OJ is not a magic, to tell. So do you all understood how to write the code for BubbleSort? Happy? See, the whole algorithm you can write, within some half an hour, 45 minutes with experience, of course. And if you want to, come up with a non-recursive version of the BubbleSort, can you try to come up with a non-recursive version of the BubbleSort? That is the homework for today. Can we try to use a loop around this for or while loop, whatever it is? Can you take this code and come up with a non-recursive version of the BubbleSort? Yeah, try it. I know you have to use 2 loops, but I want you to get experience by writing the code. One already wrote. Good. I want others to try out. Bhargav gave an awesome thing, while size minus. How awesome, Bhargav. I was thinking, no, it may take me some time to write this. So what's the story? Loop underscore BubbleSort. I don't want a base case. What should we do? While size greater than 1, does this work? What I did? Format document. Does my code work? If size is greater than 1, we will go inside. And then, so here what we should do, if swap underscore count, if it is greater than, if it is equal to 0, so if it is equal to 0, what should we do? We will break, else we have to do two things. We will again make swap underscore count to 0. Can we do this one? If swap count is equal to 0, then the array is already started. We break out of the while loop. Yeah, it will break out of the while loop. That's the point. It's already sorted. We tried to do the sorting, but it already sorted. So we come out of the while loop. Otherwise, we make swap count equal to 0, reduce size is equal to size minus 1, and go ahead and work. Are you all with me here on the code, on the loop code here? Yes? No? Maybe? I want you to, those of you who have trouble, want you to go through this code, read this code and try to understand this code and write the code by yourselves and see how it is working for you. Okay, I will stop the lecture here today. I think it's a good day. We are able to write a recursive version. We are able to write a loop version. We understood BubbleSort. We understood the time complexity of the BubbleSort. We covered quite a bit of ground. So, high five to everyone. Okay. Yeah. Vaibhav is not happy with me. I'll make it work.